Okay, so this is the review for transformations of functions or transformations of lines on a graph. Um, so on the test, the front side of the test will look just like this, where we're given basically a mix and match scenario, where we have a basic function that everything is being transformed from. On the test review you guys did today, I gave you the basic function was what is represented here by the letter b, which is fx equal to 2 to the x power. And I give you which graph that will be on the test, which on the review, b is represented by number 1 here. This graph is what you would get if you were to graph 2 to the x power. Every other equation here and graph is just a transformation of this graph right here, this equation right here on B. So for example, I went through A with you guys today, but if we add or subtract anything directly to the x, that's going to change what happens horizontally on my graph. So horizontally is your left and right directions. If I add a number to my x, like I do with A, that means it's going to shift it to the left. So if I ever add to my x, I'm going to the left. So A was going to the left one. And then anything that I add or subtract after or to my second term here, or at the end of my equation, that's going to be a vertical transformation. That's going to move my line up or down. And if I were to add, it would go up. If I subtract, it goes down. So here we are subtracting 2, so this moves my line down 2 spots. So what this equation did was it basically shifted this original equation 2 to the x power to the left one and down 2. So I'm supposed to go through this page right here and look for a graph that looks just like number 1 here, but move to the left one and down 2. And again, I went over this in class, but the one that would fit that would be number 3. Because right here's my x-axis. See that asymptote, the horizontal asymptote, moved down 2 spots, and it started curving up 1 spot earlier. So that was represented by the equation for A. Over here on C, what changed is instead of 2 to the x, it's now 2 to the negative x. And again, anytime I put a negative next to my x, it's changing the signs of all my x values. So if I come back here to this graph and I were to change, if I look at all these points and change the signs, it's going to flip my line across the y-axis. So instead of going like this, my line would then do something like this, where the curve is coming down and then asymptote is going off to the right. So I'm looking for something that flips across the y-axis, so y-axis reflection, and I'm adding 1 at the end of my equation, which is going to move it up 1. So something that flips across the y-axis and moves up 1. So this one doesn't flip. This one doesn't flip across the y-axis. So I come down here, number 5. Oh, if I compare that to 1, yes, my line did flip around. So my line flipped around and my asymptote moved up 1. So yes, this line moved up 1 and flipped across the y-axis, so this is what I would get for C. Over here on D, what changes, I now have a negative 2 to the x plus 1. So my base changed signs, and when I change the sign of my base, basically I'm changing whatever my final output is, whatever the sign is. I would be changing the output, or in other words, I'm changing all my y's. So if I'm changing all the signs of my y's, that's going to flip my line across the x-axis. So that when I have a negative base, it reflects across the x-axis. And then that plus 1 is in the exponent, so it's adding directly to the x, so it's going to be a horizontal transformation. When I add, that means I'm moving to the left. So that's a left 1 transformation as well. So I'm looking for something that looks kind of like number 1, but flipped across the x-axis and moved to the left 1 spot. So when I look across these, I only have 3 options left. The only one that's really flipping across, that's only flipping across the x-axis is this one right here. And I can look, yes, it did start curving up 1 spot earlier. So that would be represented by D. E is a little tricky as both the 2 and the x both change signs, so they're both negative. And then I have this plus 3, which means it's going up 3. But when these are both negative, or they're both changing signs, that's basically saying that I'm going to flip across the y-axis and the x-axis. So I'm going to look for something that flipped across both. So my line should be going down, and it should be curving up, and the asymptote should be on the right side as well. So if I look through, one would be 2. The only other one left is 6. Does it? Yeah, it flipped across the y-axis, and it flipped upside down. And if I look, the asymptote is 3 spots higher, so it did move up 3 spots as well. So that would be E. And by default, this is going to be F, but let's double check and make sure our answers are right. Because if we get to the end, and our final one doesn't match up with the transformation we see here, guess what? We did something wrong. So don't just assume that the last one is going to match. Make sure you check and make sure it actually matches the graph. So looking at F, we have 2 to the x minus 3 power. So again, it's going just to the x. So that tells me it's going to be a horizontal graph or a horizontal transformation. If I minus, that means it's going to shift my line to the right. So this line should be shifted to the right 3 spots. Okay, if I look through at 2 here, it should just look like 1, but to the right 3 spots. So if I check, I'm going to check the y-intercept. Okay, so if I look at the y-intercept and count to the right 3 spots, yep, that moved to the right 3 spots. So that would be F. Okay, that's what you do with the mix and match. On the next page, this is where it gives you either a new equation and figure out what happened, or it gives you a description of what it wants you to do to make a new equation, and then you're going to describe what that would do to your line. So basically what I was already doing on the front, but I'm going to just look at equations now and focus on that. I'm going to zoom in a little bit so we can see the numbers clear here. So I did 7 with you, so let's talk about 8. So if I talk about 8 here, this section just wants me to describe the transformation that occurred. So did it go up, down, left, right, reflect? What did it do? So if I look at 8, my original equation is 3 to the x plus 1 power. My new equation is going to be 3 to the x plus 4 minus 10. So I'm going to notice that my number being added changed somewhat in the exponent, and then I added a second term at the end of my equation. So first of all, I'm going to look at what happened to my exponent. To go from 1 to 4, I would have to add 3 to it. So if I added 3 to my x, that's a horizontal, and if I add, it's going to go to the left. So that moved my line to the left 3 spots. And then anything I do at the end of my equation is going to be a vertical. If I subtract with the vertical, remember it was going down. So this also moved down 10 spots. And that's all you have to do with this section. Just describe what it would do to your line. The next sections give you a linear equation and an exponential. I did an example of a linear equation with you guys in class, so let's look at the exponential. It's pretty much the same idea, but instead of using parentheses like we do with the linear equations, the exponent's already isolated, so we don't have to worry about putting it in parentheses when we plug it in. So let's look at 16. So my original equation for this section is 2 to the x minus 6 minus 3. So I've got 2 terms already. So this is my default equation. So this isn't going to move my line at all. This is what my line is already. Down here, it wants me to perform some transformations to that equation, to my line. And remember, anything I put in anything in the parentheses is going to go directly to my x. Anything outside the parentheses just goes to the end of my line. So if I were to plug in x minus 12 into where my x is, I would have 2 to the x minus 12. But again, there's already a negative 6 there. So that negative 6 is still going to stay there. That's still a part of my exponent. Okay, I could put that in parentheses 1. It doesn't really hurt, but it's not going to distribute or anything here because we're not multiplying a negative 6. We're subtracting negative 6 from x minus 12. So we would end up dropping the parentheses and combining like terms when we get to that point anyway. Okay, then my original equation already has a minus 3 term here, but my transformation wants me to add 3 to the very end of the equation. So that's a lot of different terms there. Looking at that, I want to try to simplify this as much as I can. So I'm going to combine the like terms in my exponents. So negative 12 and a negative 6. If I minus 6 from negative 12, I would get 2 to the x minus 18. And then if I combined negative 3 and 3, I would get 0. So my new equation would be just 2 to the x minus 18. But then it also wants me to describe the transformation that happened. So to do that, I'm going to come back up here to the initial transformations it wanted me to do. If I minus 12 from my x, that means I'm shifting my line to the right 12 spots. So this is an example of a right 12 shift. And then if I add 3 at the end of my equation, it's going to move up 3 spots. Okay? We're just focusing on basically 2 different parts of these equations. When you add to the x, that's your horizontal. When you add to the end of your equation, that's your vertical. And then the next section down here is where it gives you that description of what it wants you to do to your line, or what happened to your line, and it wants you to actually rewrite the equation with that description instead of giving you the adding or subtracting like it did through 11 through 18. So for example, if we look at, let's do 22. If we look at 22 wants me to do a vertical shift down 5 and a horizontal shift to the right 2 to my equation 3 to the x minus 5 plus 2. So let's do the horizontal shift to the right 2 first. So remember, I'm going to the right 2. That's like saying x plus 2, or not plus, minus 2. Okay, that's going to go directly into my x. And a vertical shift down 5 would be going to the end of my equation, a minus 5. So if I plug those into the equation, I would get 3 to the x minus 2 minus 5. Again, I could put that in parentheses. Doesn't really matter, but I'm going to end up dropping them to combine like terms anyway. And then the plus 2 minus 5, the minus 5 would go at the end there. If I combine like terms, negative 2 minus 5 would be negative 7. So it would be 3 to the x minus 7. 2 plus, or 2 minus 5 would be negative 3. So minus 3. That would be my new equation. Okay, and let's do a linear equation just to make sure we're seeing the difference between those two, since I just did 2 exponential. So 20 is a horizontal shift to the right 4. So if I apply that to 3x plus 2, remember the horizontal shift to the right, that means I'm going to be subtracting 4 to my x. When I plug that into a linear equation, I have to use parentheses because it's not isolated. It's part of the equation. So when I plug it in, it would become 3 times x minus 4 in parentheses, and then plus 2. And that would be my new equation there. And then one last thing, I'll show you the graph real quick here. On 24, my original graph is 3 to the x minus 1 power minus 5. And the new equation is 3 to the x plus 3 minus 2. So first things first, I'm going to look at how that would shift my line. So I noticed that I went from negative 1 next to the x to a plus 3. To go from negative 1 to plus 3, that means I had to add 4. If I add 4 to my x, that means I shifted to the left 4 spots. Okay? And then outside, I went from negative 5 to a negative 2. To go from negative 5 to negative 2, that means I had to add 3, which means I moved my line up 3 spots. Okay? And then to graph it, again, I find 3 points on my line. So I'm going to just grab 3 points. And I'm looking for points where they're intersecting or where the line is crossing through an intersection on the grid, so they're nice clean points. Okay, so I grab these 3 points and then I just do exactly what I just described. Left 4, up 3. So I go to the left 4 from each point. So 1, 2, 3, 4, up 3. 1, 2, 3. That is where that point would be on my new line. And then left 4, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And here's my new line. Curves quite a bit earlier. And I would label that as G. Okay? So if you can do all these things that I just showed you, you're going to do great on the test.